Okay, so this video we're looking at the intermediate value theorem for continuous functions. And like a lot of theorems, I feel like the wording of this thing sounds more complicated than the actual theorem is. So it says you got a function, f of x. It's continuous between and including a and b. And what the theorem says is it's going to take on every single value between f of a and f of b. So that means if y0 is between f of a and f of b, then somewhere between a and b, you get an x value that gives you that y value. So let me write this a slightly different way, and you can see if that makes more sense. Let's make, why isn't that writing? Come on now. Oh, here we go. Oh, geez. Okay. So we're going to make f of x continuous on AB. So if I graph just where A is and where B is, let's say A is here, B is here, and let's say f of A is here and f of B is there. So this point, B, f of B, A, f of A. So really all this theorem says is, since it's continuous, if you think about it, there's no way to get from A to B without hitting every single y value in between them, right? Otherwise, I'd have to have some sort of gap in there in order to get from one to the other. But since it's continuous, there are no gaps. So even if I go downwards first, I'm still going to hit all the values between these two y values, right? No matter what. So it might just be straight across. It might be curved up like this. It might shoot out and then, go beyond those boundaries. But no matter what, I'm going to get every y value between f of a and f of b. And that's what the intermediate value theorem says. You get all those intermediate values. So this is useful for a couple of reasons, but I'm going to give you one example that shows up a lot. And so here's the example. Show that there must be a solution to 4x cubed minus 6x squared plus 3x minus 2 equals 0, and that solution has to be between x equals 1 and x equals 2. Okay, so this is the example. Okay, so let's let f of x equal 4x cubed minus 6x squared plus 3x minus 2. Okay, so that's just a polynomial. We know polynomials are continuous everywhere. In other words, and this is a continuous function, so f is continuous. Since f is continuous, then I know that I can use the intermediate value theorem, but I feel like it's almost easier just to reason this out. Let's look at what f of 1 is. Right? F of 1 is 4 times 1 cubed minus 6 times 1 squared plus 3 times 1 minus 2, which comes out to be negative 1. And f of 2 is 4 times 2 cubed minus 6 times 2 squared plus 3 times 2 minus 2. And that ends up being 12. So if you think about what that means, I don't know what the rest of this graph looks like, but when x is 1, I'm down here at 1, negative 1. And when x is 2, I'm going to exaggerate this, here's 2, then I'm way up here somewhere at 2 comma 12. So somewhere, since f is continuous, no matter what this curve does, it's going to have to hit every y value between these 2 points. And it might do, something like this. It might just go straight up like that. But there are a lot of different ways that it could get there. But since it's continuous, it's going to have to cross this x-axis somewhere. So that means somewhere, by the intermediate value theorem, somewhere between x equals 1 and x equals 2, f of x must have a value of 0. Because over here it's negative, over here it's positive, so it's got to cross somewhere. If it wasn't continuous, then we don't know, because maybe it would do something like that, right? But it is continuous, so it's got to be connected. It has to cross the axis somewhere. So that guarantees that there's going to be a solution to this, because if this is f of x, if this side is f of x, somewhere it's got to equal 0.